On this video, I'll show you how to export HFSS 3D layout project into HFSS 3D. For that, I took one example project from over here. You can go to File, Open Example. Then all the HFSS applications you can see in a different folder. So if you want to see some HFSS 3D layout project, you can see all the 3D layout projects are over here. And over here you can see how to simulate HFSS antenna using 3D layout, and this is all under component, power divider, network, spiral, inductors. Then filters are there over here, example models, okay, different filter sections. Then FSS models are there, Jerusalem structures and FSS hexagonal types. And now we are going to take this particular model. This is the transmission line models. So there is a differential via model. So if you see this particular via, it has all kind of uh, differential line, which is a microstrip line on the top and the strip line configuration at the bottom. So it's basically microstrip line to strip line configuration. Okay, and if you want to see this more clear, 3D layout is a GUI mainly for SAPSCUP kind of application like packages PCB, where you can define my one layer is name is bottom, which is a signal layer, copper is a material property, then I have a dielectric layer with FR4 substrate, and I can mention each layer thickness over here, and like that you can have multiple layers. And the visibility also you can control it over here. So over here you can see all the layer which is in the model. It is listed out here. So you can see even metal dielectrics. If you want to see only the metal in the stack up, you can make it as a metal. And each layer you can make it hidden, hide or view. So if I click this particular thing one more time, you can see some of them are having a not a filled one. So if you want to make it completely filled, you can see this is how the model looks like. So it has some ports and it has some HFSS setup also. So first, our aim is to export this particular thing into normal HFSS 3D. What you need to do is the person has to create a HFSS setup, which already here. So I'll show you how to set it up. And HFSS 3D layout is a GUI mainly for packaging application. Then user has the ability to run this particular model in different solvers like HFSS solver. If you want to have a very good accuracy, planar EM solver, SA wave solver, many solver capabilities are here in this HFSS 3D layout. Right click and go to add HFSS solution setup. Once you add HFSS solution setup, it will ask you to simulate or mesh the frequency. So you can use single frequency or multi frequency. That is mainly recommended for multi resonant structures, which is working at 2.45, and you can enter customize the meshing frequency, and it will try to adapt your mesh for all the frequencies. You don't have any idea about what is going to be the resonant frequency of the structure, then you can use broadband, where you just enter low frequency and high frequency of your interest, and HFSS algorithm will automatically find that. So we'll go with a single adaptive machine and then click OK, and you can also enter what frequency of operation you want to see on the structure. It will automatically pop up. Click OK. Once you have HFSS set up, right click over here, export, and export to HFSS 3D model. Then it will ask you, I just want to put, okay, this is 3D model, and just save it over here. So it will automatically export this 3D layout model into HFSS 3D and always preserve all the material property, all the ports and everything. Let's see how it is coming. So if I go here and go to this particular folder, you can see this particular file is created. So I can just drag and drop it. I just drag and dropping it over here. Now you will be able to see the file is already created. Control H. Okay, so over here you can see one more interesting thing is your dielectrics which are created is extended beyond your ground planes. Okay, so that can be controlled in HFSS 3D layout. You go back here, okay, in the go back option, and you can see there is HFSS extend. Okay, then click edit button, or else you go to HFSS 3D layout, HFSS extend. So there is a option you can see horizontal padding. So it's telling that 10% of the length or can be dielectric can be extended out. If you don't want any extension, put 0 there. And this is for airbox. What should be the size of the airbox in the geometry? You can also mention 0.4% or 0.5%, or you can say I need a 10 mm. Over here in the vertical, I need a 15 mm. In the positive direction, if I click sync along positive and negative direction, it will be 15 mm. If I untick this guy and say I need a 10, only 10 mm, put mm, otherwise it will make it as a percentage, and click apply, and you can see you are not able to see any HFSS radiation box in 3D layout. If you won't like to see it, then there is an option called show, and you can see this much big radiation box is created for you. You can always edit it. Okay, and similarly you can export it one more time. So this time I'm going to 3D model underscore version 1. So once the export is over, go back to this folder, drag and drop this guy back to the. So now you will be able to see normal HFSS model. Same radiation box is created. I'm just hiding this radiation box by Control H and zoom into that. So you can see all the materials, all the wires, everything is created automatically. And one more thing over here, you can see the ports which is already there in the 3D layout also came out here. Okay, so this is a differential lines. And one more thing you can see here is the wires are segmented. So in order to get a wire, you don't have to be very smooth curvature, it can be segmented also. The quality of the wire segment can be controlled in the export by go over here. Okay, and you can see the number of segments in the 3D wire 6. You can make it as a 10 or 12 so that it will be more smoother in terms of segmentation. So that will add more mesh time. So you are losing something, you are gaining something, you are somewhere you lose. So that's why you can easily export it from the 3D layout to HFSS.